We talked in another video about what is chiral centers. And we said that those centers are sp3 carbons, and they have 4 different substituents. And the chirality is important, and we can recognize that a molecule has chirality because it lacks a symmetry. And those centers lack a symmetry. So we're gonna, it is important then to recognize in a molecule if we have chiral centers of this type of carbon, and how many do we have? So this is the exercise that we're doing here. So we're gonna mark chiral centers in the molecules that I have here on the screen. So again, what is our definition? We're looking for sp3 carbons that will have 4 different substituents attached. So similar to this. Remember, we say the lacks of symmetry. This carbon here has a hydrogen, fluorine, OH, a metal. That is chiral. And it has a mirror image that is not superimposable. So we did that. Now let's go here. Analyzing all the carbon. Carbon here that I'm pointing at, actually what it has connected is a metal, and a hydrogen. So that's not a chiral center because you have 2 metals. Each of the metals have 3 hydrogens. So not, they have 3 things the same, right? So not chiral, not chiral, not chiral. Again, this is connected to hydrogen, metal in this chain. So not. Here, pointing now at this one, this has 2 hydrogens. So already 2 substituents are the same, so not chiral. Now moving on here to this carbon, I see that here I have a hydrogen not pictured, right? So I'm going to draw it so that we remember that it's there. So we have 4 different substituents or not. We have a hydrogen. We have now this chain, and now the chain over here, notice, is different to the one traveling that way. Traveling this way, I see CH2, and then this carbon and all of that. And here, travel CH2, in that carbon. So actually, they are the same. So not a chiral center. And so if this is the case, again, what we're looking at is the connectivity. So if 2 substituents are the same, there's not a chiral center. And again, we go CH2, and then this carbon. Traveling the other way, I see CH2, and that carbon, same. Now, let's look at this is CH2, so 2 substituents are the same, CH2, not. CH2. Now, this one here, remember I have a hydrogen, right? Now, in the molecule here, I see, all right, hydrogen, the chain over to the side is different to the other sides. Now, let's analyze this chain in this chain. And again, I see here that traveling this way, CH2, and now this carbon with all this. And here has CH2, and all that. So actually, not a chiral center. 2 of the chains that are connected to that center are the same. So I'm going to make a drawing of that. So to remind us that, so chiral center, we have, say that here I have 1, 2, 3, 4 different substituents. That's what we're looking for. Now, the carbon next to it, this one here, let's analyze that. There is a hydrogen there. Remember, an sp3 carbon needs 4 bonds. So let's do that. And I'm drawing that in a dash because notice that an sp3 carbon, that's tetrahedral geometry, so we will have 2 bonds in the plane. One is on the wedge and the other is on the dash. Since I have 2 lines on the plane and 1 wedge, that means the hydrogen is on the dash. Now analyzing the substituents, metal, hydrogen, and now this chain is different to that. So this center, that is a chiral center. I want right here in the box. Now next to it is an sp2 carbon, and actually you can count that as 2 substituents of the same, so that's not a chiral center. So that is for that molecule. So now moving on to the next. We have the same pattern here. We have a carbon that has a hydrogen, but it has metal and metal, so not a chiral center. Each of the metal has 3 hydrogens, so not chiral. Now, moving on, the carbon here, let me get this one in a circle. Now, let's analyze what's attached to it. I know there is a hydrogen here, it needs 4 bonds. So it has the isopropyl group, and let's do this, isopropyl hydrogen. And now, the chain over to the side, if we count, let's say CH2, and now this carbon with a metal. Traveling this way. Now traveling the other way, I see this is CH with an OH, so entirely different. So this chain traveling this way is different to that chain. So that is a chiral center. And I'm gonna put that into a little square. That's chiral center, chiral center. And moving on to the next atom, I see here again, I need 4 bonds, so there should be a hydrogen there. So hydrogen OH, that's 2 different substituents. Now this chain over here is different to that. We see here CH2 and then that CH, and here this carbon is connected to something different. So 4 different substituents, that's also a chiral center. I'm gonna put in this little box. CH2, not chiral center. Now this one over here has a metal, a hydrogen, and now the chain over here is different to that. Here you have CH2 and the carbon with those substituents, and here you have CH2, CH2. So traveling the 2 ways is different, so that is also a chiral center. Now, let's move on to, this is CH2, CH2, so not chiral. Moving on to this molecule, here I have, that's an sp2 carbon, so that is sp3 CH2, not chiral. sp2, sp2, not chiral. CH2, CH2, not chiral. This center here, you have a hydrogen, this group, and that group is different to that, so that is chiral center. That is sp2, that's CH3, not chiral. CH2, not. Now, the group, this, the carbon here has a metal, chain over to the bottom here is different to the other 3. So that is a chiral center, and I'm using my little box again. Another chiral center, and the carbon next to it, this one here, has a hydrogen, a metal, and the 2 chains are different. So that is another chiral center. So here are the chiral centers for that molecule. The final molecule that we're going to be doing is this. Notice here I have CH2, CH2. This carbon here, which we call in bicyclic compound the bridgehead, has a hydrogen, not picture. I'm going to draw it. So hydrogen, this chain over here is different to this and that. So that is a chiral center. This is a CH2, not a chiral center, sp2 carbon. This one here, notice that it has a metal. This chain is different to that and different to that. So 4 different substituents. The other bridgehead is also a chiral center. And finally, the one on the top is not, because it has attached 2 metal groups. Now we are going to be doing more exercises about stereoisomers in other videos.